Here are some circuit components that you need to know about. Do you recognize any? Okay, when we represent these, we don't draw the components like this. Instead, we represent them using symbols which look like this. Okay, in this video, I'm going to focus on these components over here. Okay, so this component here is an open switch, and you represent it using a symbol like this, almost like an open door. And what this does is it prevents current from flowing whenever the switch is open. So that's because there's an air gap in between them. And air, if you remember, is actually good insulator, so it's got very high resistance and it doesn't allow current to flow. Now in this circuit, you can see the switch is open. A lot of people think the current will flow until it gets to the switch and then stop. That's not how it works. If the switch is open, then there's no current anywhere in the circuit. Again, we've got a switch, but this time it's closed. And we represent it using this symbol. And basically this just allows the current to pass through. Now if I draw that in a circuit, the switch here when it's closed has got very low resistance. So it's not going to use any voltage and it's not going to slow the current down. Okay, this here is a cell and the symbol for it looks like this is a thick small stick and a long thin stick. Okay, this provides a constant potential difference, basically it provides a voltage. And what's going on is inside it is chemicals and there's a reaction going on, and that turns the chemical energy into electrical potential energy, which is provided to the charge and allowing it to flow. What you need to know is that the long stick there, that part is a positive end, and the short one, the thick one there, is a negative end. And when we connect into a circuit, the current will flow from positive to negative. When you have more than one cell, we call it a battery. So it's just two cells or more put together. Again, you've got the positive end and the negative end like this. The long part is positive and the short part is negative. And current is going to flow from positive to negative. Now, let's say each of these cells is 1.5 volts. So clearly the total voltage here is going to be 3 because you just add them. If we had 3 cells like this, each 1.5, once again you add them all together because they're all connected together in the correct way. However, if I reverse one of them, see the one on the end, I'm going to reverse it, turn it around. So instead of adding, the voltage is actually going to subtract now. So if we do 1.5 plus 1.5 minus 1.5, the total is actually 1.5 volts. This component here is called the filament lamp, or sometimes referred to as a bulb. It's represented using a circle with a cross like this. And basically when current is flowing through the bulb, it heats up the filament, which is right there, and it's going to get hotter and it's going to start to glow. So ultimately what it's doing is it's turning the electrical potential energy into light, and also is going to emit it as heat to the surrounding as well. Okay, these images show resistors, and resistors are represented using a rectangle like this, and basically they oppose the flow of current. The larger the resistance, for the same voltage, you'll get a smaller current. So for example, a 1000 ohm resistor is obviously got 10 times more resistance than a 100 ohm resistor, like the one on the left. Okay, so if I apply the same voltage, you'd get a tenth of the current for the 1000 ohm resistor because it's more difficult for the current to flow through it. Images here are a few representations of variable resistors. Now they come in many different shapes and sizes. We represent them using a symbol which is just a rectangle, just like the resistor, except now it's got an arrow going through it to show that you can change the resistance. So the word variable obviously means you can change it. So as you can guess, this is a resistor whose resistance can be changed. So this means we can control the current and potential difference in the circuit using these. So for example, if I have a circuit like this with a variable resistor and a bulb, and I increase the resistance of the variable resistor, because that's what we can do, we can change the resistance, that's going to increase the resistance of the whole circuit and is going to slow the current down. So current is going to decrease. Not only that, because I increase the variable resistor's resistance, it's going to use more of the voltage, so the bulb gets less voltage. So now the bulb's getting less voltage and less current, so that means it's going to be dimmer. So the variable resistor is allowing us to control the current and potential difference in different parts of the circuit. Okay, this component here is an ammeter. You can tell by the large A on it. And its symbol is just a circle with a capital A inside it. And it basically measures the current, normally in amps. So let's say we have a bulb connected to a circuit like this. If I want to measure the current through it, I can either connect the ammeter here or here. It doesn't matter as long as I'm connecting it in series or right next to the component whose current I want to find. Okay, and the ammeter's resistance has to be very low because otherwise, adding it to circuit, you're going to start slowing the current down, and you don't want your measurement device to slow the current down. So you need to have very low resistance. This component here is clearly a voltmeter and is represented using a circle with a capital V, and it measures the potential difference across a component. Okay, so remember the key word here is difference between two parts of the circuit. So if I have a circuit here and I measure the potential difference or the voltage across the bulb, I would connect it in parallel with the bulb like this. If I want to measure the potential difference or voltage across the resistor, then I'd measure it in parallel across the resistor like this. Now let's say across the cell, then I would just connect it across the cell like that. Or if I want to measure the voltage across two components, the bulb and the resistor, I'd measure connect it between the 2 points that I'm interested in. Okay, so it must be connected in parallel. Also, a voltmeter needs to have very high resistance, unlike the ammeter. This is because we're adding an extra root, and if that root has low resistance, then the current is going to start going through the voltmeter itself, and we don't want that. So the voltmeter has very high resistance so that current doesn't flow through the voltmeter.